All right, let's start. So welcome to our talk. I hope you're enjoying EclipseCon. Last day, everyone may be a bit tired, but we're here to wake you up and load the presentation. That takes a while. Okay. I hope it comes up. Okay, I'm starting to introduce myself. I'm Jan Kühnler, and I'm working for Idioms. I'm committed to the Xtend and the Xtend project. And this is my colleague, Stefan. Would you like to introduce yourself?
No, I don't like
No?
that.
Okay. So this is just Stefan. We're both working for Idioms, and we're going to show you this morning 10 Java idioms, Stomped and Xtend. And we have that Tyrannosaur X that's going to stomp all these idioms down to better things. So this is the 10 idioms I'm going to show you. It's going to be a pretty well, machine gun-like presentation because we have so many things to show, but I hope you enjoyed it anyway. So this is pretty much demo-driven. We show you 10 idioms and how Xtend can help you make your Java developer's life much easier. So let's just jump right in. First thing I want to show is actually one of the examples we ship with Xtend, and that's the movies example. And yeah, well, you may have heard that it's a good idea to work with immutable data structures, not only for concurrency, but also to control the state of your application much better. And the problem with Java is, well, it's supported. You have to write a getter, a setter, and a final field constructor and all that stuff, and it's a lot of things, and in the end you want to use it as key in a hash map, so you have to implement hash code and equals. So just for a very simple thing, you need to write a lot of code. But it's a good pattern. We want to support that. We want many people to do that, so what can we do? In Xtend, there's a very simple way to do that. Maybe you show the Xtend code down there. So here, this data structure down there, this is our class movie, and you just specify the type of the property and the name, and put an add data annotation in front of it. And that will automatically generate getters, final field constructors, equals, and hash code for you. So no more, well, I actually spent some time debugging equals and hash code, and that is not the nicest thing on earth. Good, once you have these data structures, well, good thing about Java, who knows Java 8? Who's using Java 8? Cool. So Lambdas are really finally in the language. Lambdas are great to process lists. So you have a list and you filter it down, then you reduce it to something else, then you map a certain function on it, and you want to have the result as a list as well, or whatever. And you can do all that with a chain of functions that takes a lambda for predicates, for whatever should be executed and that like. And yeah, this is how you do it in Java. And Java 8 is already great because it has type inference for lambdas, but it's still a bit noisy. All right, you can do better. So the same thing here in Xtend is actually, well, the number of one-liners you see, and our lambdas there in square brackets, you can skip the parameter if there's a single one. Well, also if there are multiple ones, then they are just numbered. The type is inferred from the context, as in Java 8. If you skip it, it's called it, and it works like this, but it can be assigned. That means you don't have to name it in order to dereference it. So this is actually much more complicated, but in that short form, very well readable. Into the bargain, we can refer to getters by the name of the property only. That will be linked to the getter call, but well, it's much more readable. I mean, the getter setter is a good convenience for, is a good convention for encapsulation and that stuff, but you don't want to write that every time. All right, so second idiom is presented by Stefan.
Yeah, so you might think, okay, all the JVM languages now have this construct for value types, so no matter which one you look at, they all have this concept of add data. So what's so special about it? Well, the special thing is that it's not built into the language. Actually, it is just a library, and you can build your own. We call them active annotations, and they are compiler macros that allow you to change the classes that you're currently looking at, or even come up with completely new types, or read and write from files. So I'm going to show you a very simple example here. You know, you have this annoying pattern when you want to have a logger in Java. You always write the same thing. You write private final static logger, logger, get logger, logging client, Java class, get name, logger, 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 logger. And of course, nobody likes writing that, so they just copy paste it into the next file. And what happens? What happens? Same class name, yeah. Everything logs under my special class, and your admins get very frustrated. So what I did here is I wrote this active annotation called log, and it says I'm processed by the log processor. And the log processor, in its transformation phase, gets the class that I have annotated. And now I can do things with that class, like I can add a field called log, and it's going to be static, final, and the type is logger, and the initializer is just what we saw before. Logger, get logger, and then the qualified name of the class. You can see I have nice template expressions here with replacement variables and even import handling. You can see I'm referring to the type logger here, and Xtend will automatically import that into the generated Java code. So let's see how our logging client looks afterwards. You can see I have no more boilerplate code. I just say, hey, log. And the IDE is fully aware of what's happening. So when I hit autocomplete here, I see there's now a field called log. And it, of course, it also knows the type, so it knows all the methods. The outline view is aware of that too, so I can see the log field in my outline and so on. So it is just as if you had written that boilerplate yourself, but you're never going to write it by hand again. And you're going to see many more examples that are much more advanced, how you can get rid of all kinds of structural boilerplate in your code. But first, Jan is going to talk about some other very annoying missing feature in Java.
Right. Ever worked with units? So if you really do some real-world problem, you may deal with time, with length, with speed, with things like that. And yeah, in Java you can of course have methods. You can create types for a distance or for a time period or whatever, but it's kind of boring to work with these because we are kind of stuck with that method call syntax. We have to put the name of the function, in this case maybe a factory function that creates a length object. You must put that first, and this is not how you would write it in a document, okay? It's not kilometer 15, it's 15 kilometers or miles. Very in Europe here, okay? This is all European units. So what can we do? Well, there are actually two tricks here. One is operator overloading. So you can define operators for your own classes. So you can define how two lengths are added, or what happens if you divide a length by time. Okay, it's gonna be a speed. And this is cool. So you just write a method, and the name is just the operator, and you can almost you can overload almost any operator in the Xtend system with your own implementation for your classes. Okay, this is cool, but integer is a class, well, it's actually a primitive type, and you cannot add any methods to that, and this is why we have a second feature I want to show you, and that is extension methods. Extension methods is, after all, a syntactic trick. It means that when I call a method, I put the first parameter in front instead of naming it after the opening braces. So that allows me to, well, create a method that looks like it was defined on the original type, but it isn't. So what happens here is we added a method kilometers to the type int by just defining an extension method that takes an integer as the first parameter. And that allows you pretty nice syntax here. So you can see that this is well-readable code, all right? And in the end, you can even write something like kilometers per hour, and that makes sense syntactically because hour is also a static method that returns 1 hour, okay? So once again, nice syntax for a maybe pretty complex problem.
Exactly. Now, we're looking at the JUnit test here, and who thinks that JUnit is a great tool? Yeah, hopefully almost everyone agrees. test-ng users are welcome though. So the bad thing about JUnit and many other frameworks is that they make you repeat yourself a lot. So JUnit has this concept of a test annotation. This is so that you can have any kind of naming convention for your test methods. You can call them any way you want, and JUnit will look at the test annotation. But it's not really necessary if I already have a naming convention, right? Also, JUnit always makes you state that the return type of your test is void. It will actually throw an error if it's not. I don't know why it cares so much, but it will make you do that manually. Another thing is, if you want to use the assertion methods or the Hamcrest Metro library, you always need to do that static import, and you need to do it in every test, because there is no test where you don't want to use assert, right? So what I did here is I extracted this annoying boilerplate into an active annotation, and that is actually available on Maven Central already. It's called Xtend JUnit, and this annotation does all the things that I've just talked about. So my convention in my tests, and probably many other people's too, is that public methods are probably test methods and private methods are helpers. That's it. And we can make them void automatically. We can make JUnit rules. Who knows what JUnit rules are? Yeah, you need to add a public field. It's very weird. You usually don't have public fields in your code base anywhere else. So every time you do that again, you forget and you leave it private, and then you click run, and then JUnit says, you know, I see you have a rule there, but I'm not going to use it until you write public. So that is very annoying. So I removed that too and made rules public automatically. So as soon as I see the rule annotation, I just change the field visibility to public, and it's done. And also this annotation automatically imports all the nice assert methods. So I get auto-completion here for assert equals, for instance, as you can see. So no longer do I need to copy-paste the boilerplate code for my tests or write it all manually again. I just slap an add JUnit on my test case, and I'm finished and can start coding the actual tests. And another thing that has bitten me over and over again is assert equals' order. Who has mixed that up before? Who has written actual instead of expected? Everyone else is lying. So what I did here, I used Xtend's operator overloading, and I overloaded the double arrow operator to make it into an assert operator. So I said, when I say in my test something, double arrow, some matcher, or some expected value, it is an assertion, and it reads completely naturally, because I can say the article should be, or should contain the string Xtend. No longer do I need to wonder what the correct order is. And speaking of the double arrow operator, the normal implementation is also very useful.
Nice. Yeah. So Stefan really likes playing, so I programmed a little game for him. Show the game, I guess. Yeah. So I'm a big fan of JavaFX. If you know me, you may have noticed that. And it allows you to create funny things with very little lines of code, but still so this is catch the quirk. Yeah, you have to catch it, but it tries to evade, and if you manage to click on it, it's starting to jiggle a bit.
So your co-speaker is busy now.
He's busy now, yeah.
That's what he does.
So this is why I just have to kill the internet connection to get him back to life. Yeah. But you know that if you've been into UI programming, who has done any GUI programming? I guess most of you. The problem in Java is that we have Java is kind of procedural. So you create widgets, set parents, then set properties on them. So you have a linear code while you're building a tree. And if you forgot to set some layout data on some object, it's quite hard to find where that object was and why that data is missing. In Xtend, we have that double arrow operator. You see it over there. Okay. And that one allows you to specify lambda after that operator, and that is executed on the result of the expression in front. So that means I create a new image view, and then I can easily initialize it. And that way all the nesting can be shown as nesting of lambdas. And the tree you create is completely described by that nesting of lambdas. And that's pretty great. And another great feature here is that you don't have to write set fit width 100, but you can just, there's a shortcut notation that looks like an assignment. Okay, so fit width equals quirk width is actually set fit width to quirk width. And so the entire thing looks like a tree, is initialized with assignments, and looks almost declarative. So it looks almost like the XML, FXML, whatever thingy JavaFX provides, and that's cool.
Without the noise.
Without the noise, yeah. Okay, and then you see, of course, handlers can be written with Java, with Lambdas as well, and the it operator is your friend again. The it name, whatever. So one last thing here is null save operation. Who's annoyed by null checks? Okay, if you really navigate a longer expression and have to check for null on each operation, that's really annoying. In Xtend, there are actually two null save operators. One is question mark dot, means like if it's null, don't execute it. If it's not null, call the method. Okay, and of course you can change that, and you can have multiple question mark dots at a time to build such change. And the other one is Elvis operator. We called it Elvis because it looks a bit like Elvis. I guess we haven't used it here. It looks like that, and that means if the value in front is not null, that's the result of the expression. If it is null, the right value is the result. So this is very, very nice for singleton patterns, whatever. Okay, I guess it's your turn again.
So, back to active annotations. Who has heard of the term stringly typed APIs, as opposed to strongly typed APIs? So, one very annoying example is localization in Java. I guess everybody knows these property files.
Yeah, great.
Yeah. So you have these property files with named messages in them, and then you write these localized strings. Like you can have placeholders. For instance, here you say the first argument should be a number, and after that I want to have files read, and I can reference this thing with the name files_read in my Java code. Problem is, it's not some statically typed code. Instead, what I have to write is roughly something like that. First of all, I need to say, give me a resource bundle that has the name of my property file. Well, the first opportunity for an error here. I mistype it and it doesn't work, and I only know at runtime, so I need to restart my application to find out whether it's actually localizing. And then for every one of my methods, like the files read message, I need to write a Java method taking the right number of arguments, and then I need to get this string from my bundle. And as you can see, I've made it a constant, but it doesn't really make it better because I need to repeat those names from my property file in the Java code. And if I change my property file, then, well, I don't notice. Yeah. Then my application starts saying hello world everywhere on every button.
In Chinese.
In Chinese, yeah. Instead of the one I wanted. And so I wanted to get rid of this whole pattern here. And that's what I wrote the messages annotation for. So it's also available in Maven Central already. It's in the Xtend contrib library, if you're interested. And what this does is you can see this class doesn't have any real content. It just added a main method to demonstrate its function. And it is just in the same package as the property file. And that's the convention. So it looks for a property file of the same name. And if there is none, it will tell you. So if I just renamed that, it would tell me, hey, there is no property file. Okay, we have another validation shadowing that. So let's just remove it maybe. Okay, Eclipse doesn't want me to remove a file. Fine, not removing
Windows,
a file.
Windows.
Windows, yeah, great. So if that worked, it would show me an error marker saying, hey, that file doesn't exist. But Windows is saying, no, you're not gonna delete that file. Anyway, this annotation does exactly what I showed you in the other Java code. So it reads the property file at compile time, it walks over all the keys and creates a method for each one, and it even looks at the arguments in that message and adds method arguments to my method, and these are even of the correct type. So for instance here, you can see I can call the fileSRED method on my type, on my new messages type, and it takes a number as an argument. Why does it do that? Because the message said that this argument must be a number. So I even get compile errors if I do something wrong. And now let's view that side by side actually, and delete something in my property file. And as soon as I do that and the incremental build runs, you can see that there's an error marker popping up. And apparently there's another Eclipse bug that's there since Mars that doesn't show error markers properly. And if I re-edit, then my method is back again. So I get live feedback, not just when I edit Xtend types, but also if I edit external resources that I have read in my active annotations. So I can really build nice little frameworks that put a static facade in front of untyped data.
And the good thing is you can do that. You don't have to consume what we kind of prepared as examples. You can do that for your own thing. And you get a lot of tooling just by the static typing, type checking of the Eclipse IDE. And this is pretty great, I guess.
And also we encourage you to do it for your own project. So as you saw with the JUnit annotation, those were my personal tastes in JUnit tests. You have your own, and you have your own projects and best practices, and you can just extract those best practices into active annotations. All right, Jan.
I forgot what the next is about. JavaFX again. Okay. Yeah. Well, this is just by incident. That's JavaFX. It's actually about you can really have great graphics with JavaFX. You know, these things are incredibly modern and good. But when you're writing JavaFX, you may want to have an export, and in this case, I chose that as an example for code generation. So we want to transform a JavaFX scene graph to SVG, scalable vector graphics. And if you have, who has ever done code generation? Who has used Java for that? Why? Sebastian.
Because Xtend wasn't available.
Okay, maybe you show the code, the Java code for that, because Java is not really suitable for code generation. It doesn't have multi-line literals. It has the string builder thingy to concatenate strings if you want to do it right. Okay, so in the end, it's no longer possible to see what you actually generate, and you have to care about all the white space and line breaks, and maybe you have Windows and Mac users on the same code base, so line breaks are an issue, and you know, this is all easy to screw up. This is why people are using template languages, and this is why how Xtend initially started. We wanted to write it a code generation language, but then it became much better. Okay, so one of the first features we implemented in Xtend is these template expressions. These are the triple single quote, or is it single? Yep. Triple single quotes, who delimit it. And within these quotes, of course, there's only text. This is the text that goes into the output. So the result is a string, and you can decide yourself whether that goes into a file or to console or to DevNull or whatever. And of course, you want to have some information from the outside, some information from your model inside that. So you need these French quotes, the guillemets. And within the guillemets, you can write any kind of expression, and the string value of that is inserted at this place. So this is not just to refer to fields or something. This is you can write any kind of expression. And then you have loops. So you may have repetitive things to generate. For that, you have a for loop here. So the special thing about that for loop is, of course, the body is a template expression again. This is why it doesn't. Is not exactly the same as the for loop in Xtend, the normal for loop. And there's also if for conditional generation. Good, so this is, I mean, code generation is not difficult. These are the base concepts. But what is difficult in code generation is white space handling. Because, well, we are writing a program, we want it to be readable. At the same time, we want to control what kind of white space goes into the output. And this is two orthogonal aspects which often contradict. So what we have here, I don't know why we don't see it. Did you switch it off?
No.
No?
It's just the projector is not showing.
Oh, it's the projector again.
I'll try to make the different color.
Yeah. Yeah, when you open a template, you see there's white space and orange space. No, what color would you do this? Usually it's gray.
Text.
Hmm?
Sorry? Template text.
Template text. Yeah,
yeah,
this one.
to
Pink. Yeah, pink is
would be
good.
perfect.
Okay, so now you see white space and pink space. White space is something that doesn't go into the output. This is there because we are inside a method. We want to indent the method body. We're inside a for loop. We want to indent the for body. And everything else is colored in a different color. And this is not something you have to do. This is something we figure out. We have an algorithm that automatically does that. And it also does something much more sophisticated. What are you doing? That is, for example, look at the for loop. We're calling within the for loop, we call another template. And that one has an indentation in front. And that indentation is actually put in front of everything that comes back there. So all the line breaks are replaced by the indentation, such that if you really generate code that is very, very indented, but do it in methods or recursively, you can still start running your template from the left. Okay? Right, last aspect here is, yeah?
May I make it look nice again?
Well, okay, last thing here is when you're generating code, you're often navigating or traversing a heterogeneous structure. In this case, it's various kinds of shapes from JavaFX, and you want to do different actions with regard to the type of object you're currently on. And to do that in Java, you have to write an instance of Cascade every time. So this could be a rectangle, this could be a circle, this could be and if it's a circle, then cast to circle and call the circle method. If it's this is quite annoying, and it's also error prone because the order in which you execute these type checks and casts matters. In Xtend, we have a feature that's called dispatch method. So by just marking a method as dispatch and overloading it for different types, the instance of Cascade is created for you automatically, and it's also taking respect to the class structure, to the inheritance structure. So it's pretty useful.
All right, we've talked about stringly typed APIs before, and I just want to show you one more, well, popular library that does that. Has anybody heard of Spark? It's a little web framework or REST framework. Yeah. So what they do here, it has a quite nice syntax. If you use Java 8, you can use Lambdas for the callbacks. And what you do is you just define your routes. And then for every route, you need to define what to do with the request and response. So it's quite simple API. But there's a problem here again. I write that my route has the parameter name. And then if I want to use that in my handler, I need to say request params name. And there we go again, another opportunity to get it wrong and wonder why it doesn't run and only find out at runtime. So what I did here instead is I wrote a little Spark app annotation that works with get annotations. And you see here two methods. Both are named hello, so usually that would be compile error, right? But they have different paths in their get annotations. So the one just goes to hello and the other goes to hello name. So let's have a look at the outline of this thing, and you can see that one of the hello methods takes a request and a response, and the other takes a request, a response, and a string called name. So instead of saying request params and then name in the string, I get static typing here. And if I ever change this, then I get a compile error immediately, and not a runtime error sometime later. And also, of course, I get autocompletion in here, so I know that there is this thing called name. So this, again, allows you to put little static wrappers in front of these kinds of libraries that make you write dynamic or stringly typed code in Java. Okay, we're almost through with the framework zoo.
Yeah. So one more framework. We just want to show you that to once again state that Xtend really can be used everywhere where you use Java, because we're compiling to Java code, we're using Java's type system as is. And so there's no friction, there's no additional things that make integration with any Java framework a problem. So here's another framework that is, what was it? RX Java.
RX Java.
Yeah.
Reactive is all the...
Reactive, it's so reactive, yeah. And in fact, usually we try to be as good as JDT, because JDT is really great, but in this case, we are better. This is why we show it. So Look over it here. It's
Auto-completion.
Auto-completion in Java within Lambdas is kind of missing in JDT. So you have to give it a lot of context in order to get reasonable proposals. But in Xtend it works great. So well, maybe the only place where we're really better than JDT, but okay. we're younger.
Okay, so we've kept it until last because this is Eclipse gone, but as you might know, sadly enough, Google decided to pull all the Android developers to Android Studio. And that meant for a while they could no longer use Xtend, which really is a shame. But we've been busy. So now you can use Xtend in IntelliJ, and you can use Xtend with Android Studio as a result. And we have a really nice community there, and one of them is called Toby Kurian. He's from South Africa and has written some really cool active annotations for Android development. So if you're not familiar with Android development, I'm just going to show you what you usually do. You have this cool designer window here, and you added an XML file for your view. The reason they did an XML file is because they want different layouts for different kinds of devices, so you cannot statically write it down. At least that was their decision, that you cannot do that statically. And the only thing that really matters on the Java side is these IDs here. So I have a text field called, or text view called main article, and a button called main load article. So this little app will load a random Wikipedia article for me when I press the button. Very useful. And what you usually do in the Java code that corresponds to that is you ask Android for the widget with this ID. At least they statically compile a helper class that contains all the IDs. So we're away from stringly typing. Yay. But you still need to know that main load article was a button and not, I don't know, a checkbox for that main article is actually a text view and not something completely different. So you just ask for some element and then you need to downcast it to whatever you want. Or you need to annotate a field of the correct type. And if you mess it up, you just get a runtime error and no compile error. That really sucks. So Toby did this Android activity annotation. And what it does is it looks at your view layout and it reads in all the IDs and the corresponding types like button and text view and generates fields in your activity class. So now I get auto-completion here and I can say, for instance, main article dot something text equals hello. Just as a little example. So I get all my widgets in auto-completion by default. And so what he did here, he also added some cool builder methods for asynchronous computation. And so writing this Wikipedia loader was really straightforward. I just say async given a progress monitor, reading some data from wikipedia.com or .org. And then once I have the result, I say main article.text equals that result. And I'm afraid we won't have time to show that live because starting the Android debugger, as you might know, takes ages. And this is why this is so great. Because the turnarounds in Android developments are so low, any kind of static tooling that you can get is worth a ton of money. So Xtend can really help you speed up your development and speed up your turnarounds. Okay, so let's wrap up what we learned today. We can really condense our code bases by using Xtend's features that go beyond Java. And we have the same type system, the same SDK, so you can do anything that you're used to, and you won't get confused by any new, completely new type system, for instance, but you get concise Lambda expressions. Even when we talk about Java 8, Xtend, I guess you can agree, still looks much, much nicer. You get extension methods, so you can extend existing types. You get operator overloading, so you can finally work with units properly, for instance. You get dynamic dispatch if you need it for traversing object graphs. You get really awesome template expressions, in my opinion, the best templating language there is. You can easily build builders. Actually, you don't need to write any code for that, it just works out of the box. Property access is simple. Many other little things that annoy you in Java, like semicolons and empty braces, can be left out. You get null-type operators, which are very useful, and of course, active annotations, which you can use to tailor your development experience to your own patterns that you have in your company. All right, so
yeah, that's it. I hope you enjoyed it. Maybe we have time for one question. Yes?
Regarding active annotations, what is the difficulty of using active annotations on Java classes?
So the question is, what's the difficulty of using active annotations on Java classes? Active annotations actually are executed in the transformation step from Xtend code to Java code. This is why we can hook in there, but we cannot change existing Java classes. So we could with some very heavyweight whatever things. We didn't want to build another aspect or whatever framework, but you know, the good thing is it gives you the concise syntax on the Xtend side, but still the safety and everything you need and all the boilerplate on the Java side. When you debug through it, you can even look at the Java code and you know exactly what's going on. So this is really to avoid magic. Okay, it's always almost clear what's happening. Yeah.
All right, more questions?
Okay.
Then enjoy the last day.
Yeah, thank you.